Hello, and thank you for watching this help video. In this example, we have the polynomial function. I'm going to show you how to factor this polynomial, identify the zeros and the respective multiplicity. Now, in order to factor this requires a technique called grouping. So what we're going to do is literally group the first two terms. So we're going to, using parentheses, we're going to group the first two terms, x to the third power plus 5x to the second, put a plus sign right here, and group the last two terms, negative 25x minus 125. And the way that we factor this, like by grouping, is that we look for the greatest common factor among the two groups. So like in the first group, I see that they both have x's, and they have at least an x to the second power, so I'm going to factor out x to the second power. And that's going to leave us with x plus 5 in the parentheses when I take out the x to the second power. Now, having done that, this here, what I'm left inside my parentheses, this is the clue and my indication that I'm going to do the same. I'm going to do something again similar. I'm going to get the greatest common factor among these two terms, but I have to be left with an x plus 5. And that's the beautiful thing about this technique, that if this technique works, then factoring out the greatest common factor among these two terms should give me again an x plus 5. So I'm going to put a plus sign, give myself a little space, and inside this parentheses I'm going to write x plus 5. Now if this technique is going to work, then the value that I'm going to factor out in the second group is essentially just going to be the leading coefficient. So if I divide out negative 25 from a negative 25, that does give me 1. So let me just write that negative 25 right here. And that does in fact give me 1. Negative 25 divided by negative 25 does equal to 1. Now let's check that it actually works with the second value. Negative 125 divided by, again, negative 25. Factoring out that negative 25. Negative divided by negative is positive. And yes, 125 divided by 25 equals to 5. So this is going to be the second term that I end up with. And again, this technique, if this is a proper form of using this technique, or let me rephrase, if this technique works, then this is going to be true every single time. Factoring out an x squared here is going to leave you again with a binomial, and on the second binomial should match up to that. And we should end up with that these two again are the same by simply factoring out the coefficient to the first term in the second group. Now, what do we do from here? From here, we're going to factor out the x plus 5. So if I factor this out and I take out the x plus 5 from both of these terms, okay, so I take this out and I take this out and factor that out, what I'm going to be left among these two terms here is simply going to be the x squared and the positive negative 25, the sum of negative 25, which can be rewritten as minus 25. So I have the product of these two things. And if I multiply them out, again, if I multiply using FOIL, this times this is going to give me x to the third power. This times this gives me my negative 25x. Multiplying these two will be my positive 5x to the second power. And multiplying the 5 with the negative 25 gives me the negative 125. So this is the factored form, not the completely factored form, but the factored form of this part right there. Now I would normally stop right here, but you'll notice that the second factor that I have here, x squared minus 25, is a difference of squares. So I can rewrite that part, and let me highlight it in blue. I can rewrite that as the following factors. By a difference of squares, this is going to break up as to x plus 5 and x minus 5. So here's the complete factored form to our polynomial function. Multiplying x plus 5, and x minus 5, again, is exactly how we are going to end up with this right there. And that correlates again to the linear factorization theorem. Since I have x to the third power, that means that I can multiply a total of 3 linear factors, and I have them right there. I have figured out what 3 lines can be multiplied to create this polynomial. So the complete factor form of this would be f of x equals to x plus 5 to the second power, since I have 2 of them, times x minus 5. Which means that our x-intercepts will be negative 5 and positive 5. Which then implies that the multiplicity of negative 5 is 2, and the multiplicity of positive 5 would be 1. Sorry, I wrote 5 here. I meant to write 2. So x equals negative 5 a total of 2 times. All right, so we need a negative 5 to make this equal to 0 one time, and then we need another negative 5 to make this equal to 0 a second time. And then, of course, we need a positive 5 to make that equal to 0. So plugging in negative 5 2 times and plugging in positive 5 only one time will make any of those number of times will make this equal to 0. So there's the respective multiplicities. I hope this video was helpful, and I appreciate you watching.